White off-road vehicle MgcSTEM PWM 2.0 LVP battery adapter simple modification 2. First, put the time to use video and content framework. Hello everyone. Today I use this PWM 2.0 module and this battery adapter to upgrade the power wheels. If you don't want to buy variable speed pedals and want a simple and fast upgrade, you can refer to this solution. After the upgrade, the power wheels can directly use 20V DeWALT tool batteries with soft start function, which can protect the power wheel motor and gears. There is low voltage protection to prevent battery damage. Before modifying a car, we must first understand the wiring of the original car. Because each car has its own internal wiring structure and accessories, we first understand the wiring principle of the original car and then make changes. We first disassemble the car parts and check the internal wiring. Disassemble the accessories in the order of seat cushion, engine hood, windshield, steering wheel, and control panel. This is the circuit diagram of this car drawn by removing some accessories and observing and measuring. Comparing the circuit diagram with the original car accessories, let's take a look at them one by one. This is the battery, corresponding to this part of the schematic diagram. This is the motherboard, corresponding to this part of the schematic diagram. This charging port, corresponding to this part of the schematic diagram. These two are the rear wheel motors, corresponding to these two motors in the schematic diagram. This is the power switch, corresponding to this power switch in the schematic diagram. This is the switch that controls the front and rear shaking function, corresponding to this switch in the schematic diagram. This is the light switch, corresponding to this light switch in the schematic diagram. This is the shifter, corresponding to this one in the schematic diagram. This is the pedal, corresponding to this pedal in the schematic diagram. This is the front wheel steering motor, corresponding to this motor in the schematic diagram. There are also other lighting, audio, and other circuits that correspond to this part in the diagram. Based on this principle, our upgrade ideas are as follows. Since the original car voltage is 12V and there is this module inside, if we directly connect the 20V tool battery to both ends of the original battery line, the module will be burned. So when we use the controller, we will bypass the original control module. We need a PWM module, a battery adapter, a 3-pin brake pedal, a 6-pin shifter, and a connecting wire. The solution is based on PWM 2.0 configuration A mode. Modification principle. Since the original car is 12V, it is now changed to a DeWALT 20V tool battery. Therefore, the lights, horns, remote controls, etc. of the original car connected to this mainboard module cannot be used and must be shielded. At the same time, the original car's brake pedal is a 2-pin pedal, which needs to be replaced with a 3-pin pedal. In addition, the original car's shifter also needs to be replaced, because the shifter of this car controls the gear position through the relay on the circuit board with 3 pins, and the mainboard cannot be used here, so it needs to be replaced with a 6-pin independent shifter. The 6-pin independent shifter can realize forward, neutral, and reverse functions. It is equivalent to a double-pole, double-throw switch. See this picture. When the switch is switched to the right, the current flows through PWM M+ to the 4th pin of the shifter, and then to the 3rd pin of the shifter through the connecting wire. Then it flows through the 2nd pin of the shifter to motor M+. Then it passes through motor M-, shifter 5, 6, 1, and then returns to PWM M-. When the switch is switched to the left, the current path is PWM M+, shifter 4, 5, motor M+, then shifter 2, 1, and finally PWM M-. When the switch is switched to the middle, the neutral gear is achieved. Look at this picture. The modification plan only uses the rear wheel motor and main switch in the blue box in the wiring diagram, combined with the parts that need to be replaced. So you need to cut the wires of this, and these parts in the picture and reconnect them. See this diagram for specific connection principles and methods. Looking at the upgraded circuit diagram, the power supply is connected by a tool battery adapter. I use this automatic battery adapter with LVP function here. The difference between it and ordinary adapters is that it has an electronic switch and low voltage protection function. And the interface end is added for easy connection, including the series or parallel connection between batteries. I will start the explanation in the order of current flowing from battery to load. The battery adapter comes out to connect the fuse. The original car fuse has a relatively small power, so I replace this larger fuse. The fuse is connected to the main switch. Then the main switch comes out to connect the brake pedal. The principle of the brake pedal is that when the pedal is not pressed, 1 and 2 are connected and the motor is short-circuited to act as a brake. When the pedal is pressed, 2 and 3 are connected, and the current flows through 2 to the PWM module P+. The current is modulated by the PWM module, and then flows from PWM M+ to the shifter, and then to the motor M+. Finally, the current passes through the motor M to PWM M-. Then PWM P is connected to the battery bat-, and the current flows to the negative electrode of the battery through this guide. The entire line connection must be connected in this order. After the line connection is powered on, the PWM 2.0B module is configured to a mode, and then the required maximum PWM value, soft start time, and low voltage protection value are set. Upgrade wiring steps. Now, let's do the actual modification of the car. First, connect the new shifter's own wiring in series, and follow the corresponding physical objects and schematics mentioned above. For wiring, I use the following tools and cables. The shifter needs 4 cables of corresponding lengths to connect to the PWM module and the motor. The connection between the shifter pins also requires 2 short cables in series. After these 6 wires are ready, we start to connect them. The 3 pins below the shifter correspond to 1, 2, and 3 in the figure. The 3 pins above correspond to 4, 5, and 6 in the figure. First, connect the 2 middle pins, which are pins 2 and 5 in the figure, to a long wire to the motor and fix them with heat shrink tubing. Then connect the 2 pins 3 and 4 in the figure in series and connect a long line to PWM at the 4th pin, and fix the pins with heat shrink tubes. Finally, connect the 2 pins 1 and 6 in the figure in series, and connect a long line to PWM at the 1st pin, and fix the pins with heat shrink tubes. If you don't have heat shrink tubes, you must use other insulating materials instead to avoid contact short circuits. The entire shifter is connected in series like this. Formal modification. Refer to the schematic diagram to disconnect the original car panel, main switch, shifter, and rear wheel motor connection. Specific disconnection operation. Panel line corresponds to this disconnection part in the schematic diagram, and this part is actually disconnected in the power wheels, and the old pedal is removed. The main switch corresponds to this part in the schematic diagram, and this part is actually disconnected. The shifter corresponds to this part in the schematic diagram, and this part is actually disconnected, and the old shifter is removed. The rear wheel motor line corresponds to this part in the schematic diagram, and this part is actually disconnected. Next, install the new shifter. Prepare the connection wires and start connecting them. The connection is divided into 3 steps. The first step is to connect all the wires between the battery adapter and the PWM. According to the connection diagram, the negative pole of the battery adapter is connected to the PWM port, and a wire is used to connect the two ports. Then connect the positive wire. The positive pole of the battery adapter is connected to the fuse, and one end of the fuse wire is connected to the positive pole of the adapter. The other end is connected to the switch according to the schematic diagram, so it is directly connected to one end of the switch. Then the other end of the switch is connected to the pedal. Here, you must pay attention to the position of the connection pins, and you must not connect them wrong. You need to use a multimeter to measure the two states of the pedal being pressed and not pressed, and determine the positions of the pedal pins 1, 2, and 3. After testing, the other end of the corresponding switch is connected to the pedal 3 pin, the 2 pin is connected to the PWM P+ port, and the 1 pin is connected to the PWM M port. Fix the brake pedal. So that the battery adapter and PWM are connected. Note that the positive and negative poles cannot be connected incorrectly. The second step is to connect the PWM module to the shifter, and connect the two incoming wires reserved by the shifter to the PWM M+ and M ports respectively. These are the two ports, and the screws must be fixed firmly. In this way, the connection between PWM and the shifter is complete. The third step is to connect the shifter to the motor. The two output wires of the shifter in the circuit diagram are connected to the motor respectively. The extra wires were disconnected before, and the corresponding wires are connected to this one and the other one. In this way, the shifter and the motor are connected. During the entire wiring process, all connections must be well insulated to avoid contact short circuits. If the vehicle is in reverse in the forward gear during the subsequent driving test, just swap the two wires connecting the shifter to the motor. In this way, the positive and negative poles of the motor are swapped, and the direction of wheel rotation is consistent with the shifter. The circuit is now connected. Install the battery and you can debug it. Connect the battery, turn on the power switch, shift the gear to the stop position, and press the pedal to power on. See how PWM responds. At this time, you can see the PWM indicator light on, indicating that it has started to work normally. Now you can set the speed, soft start time, and low voltage protection value. Note that in this mode, when setting the speed, be sure to put the shifter in the stop position and then set the PWM module to avoid the wheel turning and shifting during the setting process. Set the speed. Press the pedal to power on, turn the PWM switch to the P position, and the numbers on the screen will indicate the percentage of the current speed. Short press the up or down key, and the numbers on the screen will flash. Press the up or down key to adjust the desired maximum speed percentage. I want a faster speed, so I adjust the number to 100. 100% is the maximum speed. If your child is young and thinks the speed is too fast, you can set a suitable value less than 100. After setting, be sure to press the OK key to save the setting. The speed is set. Then set the soft start time. Press the pedal to power on, turn the PWM switch to the T position, and the screen number indicates the current soft start time. At this time, short press the up or down key, and the screen number flashes. At this time, press the up or down key to adjust the desired soft start time. The setting range is 0 to 30 seconds, and the default is 10. If you want a softer start, you can set a larger value so that the impact on the motor and shifter will be smaller. If you want to start faster, set a smaller value. Test and set according to your needs. At present, I set it to 10 seconds. After setting, be sure to press the OK key to save the setting. The soft start time is set. Finally, set the low voltage protection value. Turn the PWM switch to the V position, and the screen number indicates the current battery voltage. At this time, short press the up or down key, and the screen number flashes, and the displayed value is the currently set low voltage protection value. At this time, press the up or down key to adjust the desired value. I use a DeWALT 20V tool battery, and usually its lowest protection voltage is 16.5 V, so we set it to 16.5 V here. Short press the OK key to confirm the setting. Note that after the setting takes effect, the LED stops flashing and switches to displaying the current battery voltage status. So when the battery voltage is lower than 16.5 V, the LED will display LO, and the PWM will stop outputting. However, please note that although PWM has low voltage protection, it stops output. It can prevent children from using it for a long time, and the battery will be discharged to a value below the minimum voltage in a few hours, thus causing battery damage. However, the PWM chip itself will continue to work and consume a small amount of power. So I also use this adapter with low voltage protection. After it is disconnected from the low voltage, it will not consume power from the battery. I set the low voltage protection threshold of the adapter. CH16.5V, CL16V. In this way, when the voltage is lower than 16V, the battery will no longer output voltage, thereby further protecting the battery from overuse. In this way, even if you forget to take out the battery for a few weeks or a month, it should not be over-discharged. However, the battery itself will self-discharge. For batteries that are not used for a long time, it is recommended to take them out and charge them every once in a while to keep the battery active. Now fix the wires and install the vehicle, and you can use it normally. Watch the video to see the effect of the upgrade and modification.